Okay, so in this problem we have two functions, f of x and g of x. And we know that algebraically they're the same, because if I take the 2x squared and apply the squared, it's 2 squared x squared, which we know is the 4x squared. So algebraically, these are the same. And graphically, when it's all said and done, the graphs are all also the same. But this is a transformation, and this is a different transformation. So there's two different transformations that have transferred x squared into the same graph. So let's break down the transformations and see what's going on. So if I consider this first one, here is x squared, the red curve, and the blue curve is 4x squared. When I have a 4 times the function, this here is a vertical stretch parallel to the y-axis by a factor of 4. Which means that if I had this initial point here, the red curve, I had the point here that was, I'll go this side, this was 1, 1. Well, that means vertical stretch multiplied by 4. So that means the new point will be transformed into 1, 4. And so if you look at this, it was moved into here, 1, 4. Okay, every point is moved up or multiplied by a factor of 4. So similarly, if I look at 2, 4, it will end up being at 2, 4 times 4 will be up at 16. Whereas if I do the horizontal stretch, and think about the horizontal stretch, my original curve at 1, 1, here's 1, 1. Well, this here, when it's inside the function is all being, it means it's going to be a horizontal transformation on the x value, a horizontal stretch, or what we say a stretch parallel to the x-axis by a scale factor of not 2, but of 1/2. And so what happens to this point 1, 1 is this value 1 becomes 1/2. It becomes this point here, 1/2, 1. Similarly, if I would take the point 2, 4, 2, 4, if I stretch it in, it's going to become this point here, 1, 4. And you can see that it's the exact same graph happening in a different way. Before it was moving it up, now it's moving it inwards. So that's the difference between a horizontal stretch and a vertical stretch.